All right, hey Earth Science folks, let's take a look at the sun's energy, heat, light, and let's think about what we've got. All right, if we're looking at a candle that is across the room, can you feel the heat from that candle? It's all the way across the big room. No, you can't feel the heat. All right, if you were right next to the candle, yeah, you can feel some heat there. But if I put some distance between me and the candle, I'm not feeling any heat. But can you see the light? Yes. Yes, you can. Okay, the light travels very far, very easily, and I can see light that's coming from huge distances away. Okay, from the sun, that's a long ways away, and I can see it very clearly. And also stars that are so far away, and I can see that light. Okay, so heat and light. Now, when we look at our diagram here, I'm going to think about the sun. This graph is showing me what kind of energy the sun is releasing, and most of it, this big peak in the graph, most of the energy the sun releases is visible light. Almost half of the energy that the sun releases is visible light. And then we see other types that the sun releases. Over here, I see infrared, all right? And one thing I'm gonna tell you about infrared is that whenever you see that word, infrared, we're going to think about heat. Okay, infrared equals heat. It's a type of energy. The sun releases it, but heat is pretty useless. Like we cannot we cannot have a warm enough Earth just by the heat energy that the sun releases, because it releases so much visible light. So now, thinking about this whole process, here comes the solar radiation. Some of it's ultraviolet, some of it is visible light. Actually, most of it is visible light. And then some of it's infrared, and then there's some other things mixed in there too. But most of it is visible light. One thing that hopefully you saw in the simulation is none of these gases in the atmosphere interacted with visible light. And so the visible light makes it all the way to the surface pretty easily. Some of it reflects back out into space. Okay, it's gone. But a lot of it is absorbed by the earth. And if you've ever been in a parking lot in the summer, and it's like one of those blacktop parking lots, you know that the surface of the earth can get pretty warm. And if you put your hand above that surface, you can actually feel the heat. Okay, so the earth's surface is heated up, and then it releases heat back up. Infrared equals heat, so it releases the heat, and that heat is going to head towards space, and some of it will make it out of the atmosphere, and it's gone from us forever. But the infrared energy that you saw in the simulation interacts with some of these greenhouse gases. So water vapor, carbon dioxide, methane will absorb some of this energy, and then it might send it back down. And that means that heat energy is being kept on Earth. And this is a good thing, because without this effect, without the greenhouse effect, it would not be warm enough on Earth for us to survive. But if we think about an actual greenhouse, we have all that light coming in, heats up the insides, and then the heat tries to get out and can't get back through the glass. So it gets warm inside here. What would happen if you put thicker glass in? Because if you have thin glass, the visible light would get in no problem. It would heat up, and then this infrared energy would go up, and a lot of it would be trapped in, but some of it would still make it out. But if you put in thicker glass, then less and less heat is going to make it out of the greenhouse. So if these gases are like the glass in a greenhouse, they let visible light in, but when the heat tries to get out, they might block it. The more of these we put in the atmosphere, the more of this heat is going to be blocked, and the less of it will leave the earth, and so we're going to heat up. Okay, So this is why they're called greenhouse gases, because they work to keep in the heat just like a greenhouse. And that energy comes from visible light from the sun. All right, let me know if you have any questions. This is a huge idea, and so we need to make sure we're good with this, and then we're going to go forward and see what exactly is changing with the Earth in order to make this a problem.